I'll go ahead and fire up VidSync here. I've got all of our files already started in VidSync, but we'll just start a new one from scratch for the demonstration here. So I just opened VidSync. This is the untitled new document window. I'm gonna go to add clip, name it left camera, choose file, and we're gonna go to the videos left. I've got all of our left camera videos on one hard drive and all of our right camera videos on another hard drive, with the thinking being that it can read a little bit faster from the two drives separately than trying to read the video files both off the same drive at once. So we're going to go to 2015-06-22. That's going to be from the June Clearwater data set. Yeah, that's the data set that we want. So we're loading the left camera clip. We're going to shrink it down a little bit there so it's not quite so big. So we're going down to 2/3 size on that clip. Now we're going to add the right camera. Videos right, hard drive, June 2015. Okay, so we're just loading the files right now from the left and the right video cameras. So we've got these right now. We'll go ahead and save the file. We're going to give it a project name, 2015-06-22. That's site 2 on that date. And I'm going to put demo on there too. Alright, so now it's saved so that if the program were to crash or we have to close and go back or something, we can come back and we've already got everything that we've done so far. Now, these videos are always pretty close to synchronized to begin with. I'm going to go ahead and just play them forward to find a common point to kind of synchronize them on. So I'm using the mouse wheel right now to step frame by frame through these videos, and I'm kind of looking for the point where you begin to see some white from that fish opening its mouth on that prey capture attempt, and that looks like that's about, I don't know, that's pretty close. That's not the best thing. So we got kind of close to a synchronization there, probably on this fish grabbing a piece of food. Now we're going to go somewhere else in the video. You notice when I click this lock sync button, that's what actually synchronizes the two videos, so they're going to play in lockstep from here on. We don't know if we've got them synchronized perfectly, but now we're pretty close, and we can navigate around anywhere in the video knowing that they'll be pretty close, and we can find some sort of event that is easier to synchronize to. We actually, toward the end of the video, somewhere we'll have a spot where we actually, I don't think we did it for this one. Let's see. I might have actually chosen the wrong video to do this with, so we might have to start over.
This is the most
there it is.
Upstream pool, right, that we shot on that day, or where is this?
So I think this was the first day that we were out on the Clearwater, and it was the second pool that we did.
Okay.
So it was the one that we kind of went across the river. Okay, so yeah, I don't know if we've got a synchronization. We do have the calibration, so we can go ahead and do this. I don't think we did a synchronization with an LED light or something, which is what we'll do sometimes to make a really easy point to synchronize on, is flash an LED light in front of the camera. But these are all so close anyway, we can just find somewhere that the fish are doing something we can sync on. So as long as we do have the calibration
so why not
video,
sync on the calibration?
It's just a little bit hard to find something happening in the calibration frames that you can tell exactly that you're on the same frame in both cameras. I mean, it's obviously fairly close, but you know, like you could maybe look at when one of these bubbles comes out of the bottom or something, but you're not sure which bubble is which necessarily.
You need like a clock on the
So yeah, like
calibration.
yeah, like a clock is a useful thing if you're in the lab and have access to that. Otherwise, an LED light is helpful. But we're gonna go to where one of these fish is feeding up close to the cameras. And we're gonna hit play there and just see that. Now there was pretty good. So I'm using the mouse wheel to step frame by frame. You can do that whether you've got the videos synchronized or not. If you have the mouse over the video, you can use the mouse wheel to frame step. So there's where the mouth is like totally closed and then it begins to open. There's kind of the first one where it's open sort of wide. So we're going to try to find that in this other one. So we're going to unlock the sync now by checking that button and frame step forward to where this fish...
So the video doesn't have a frame counter that would allow you to synchronize both cameras.
No. It doesn't have that sort of thing. We just have to go by what we can see on the video. And see there, we came to where this fish is coming out, and there's the first frame where that mouth really opens up wide. You can see it's a pretty similar portion of that maneuver now in both cameras. So now we're going to lock sync on that.
So most cameras have a timestamp. Do these cameras not? I mean, this just seems
most of them don't
a
actually
little
put the
difficult to do.
Well, most of them don't actually put the timestamp directly on the video. And even if they do, the timestamp is measured relative to the particular camera, and it's not going to be exactly synchronized because you can't get both cameras, you know, synced up to an atomic clock somewhere so that they both know exactly what time it is. So you kind of need to do this anyway to get synchronized to within the nearest half of a frame, which is what you can get by this method. So now we've got it all synced up, and you can see now everything that happens is happening at exactly the same time in both cameras. Yep, so alright, now that we've synced it well, I'm going to save it again. I just hit Command S to save, and it comes in handy to just reflexively hit Command S a lot, just in case. Alright, so now we've got it all synced. The next step is going to be to do the calibration. And there are a few different steps to this. There's the distortion calibration and then the 3D calibration. So we're going to jump ahead to in the video, and this is like this slider up here. You can control where you are in the video by dragging that thing around, just like you would in any other video player, pretty much. This whole bar up here is like customized controls for VidSync that allow you to play it back in a whole bunch of different ways. And I guess maybe I'll go over that quickly first. So you've got up here in the top left just a regular play and pause. That one is to play backward, and anytime you hit any of the play buttons, there are lots of different play buttons for different speeds or directions. You can always go back to that pause button to stop it. In fact, you can also click on any of the play buttons while it's playing to use them as a pause button, which just makes things a little bit faster so you don't have to go back and forth between buttons if you're trying to play pause, play, pause, play, pause. These two with the little dots, the triangle and vertical line, those are to step it frame by frame. If you want to do that by clicking instead of, or if you don't have access to a mouse with a nice mouse wheel, it's really useful for VidSync to have a mouse like the one that we bought here that has a mouse wheel that kind of gives you a good like tactile feel every time you do one click on it. So that gives you like one frame. And this one actually, you can turn that on and off with this little button that we've got here. So you do that, and then it becomes a smooth mouse wheel, which is kind of annoying because you can't really tell when you're going frame by frame. So if you ever accidentally click it into that smooth mode, just know you can press that button to get back the nice frame by frame clicks. Right, there's an instant replay here. This one is to replay the last 2 seconds of video at a normal rate. That comes in really handy when you are watching foraging attempts or something and you see the fish look like it just grabbed something and you want to watch it a few more times to reinterpret exactly what happens, because sometimes it doesn't look the same as it did at first glance when you rewatch something. So it's a little bit easier to see that we're rewatching the same thing here if we click that several times when there are actually fish on the screen. So you can see it's kind of an instant replay, and that's for the last 2 seconds. The buttons over here with hands are to play while the button is pressed down and pause as soon as you lift it up. That, it turns out to just be kind of more of a convenient and a responsive way to navigate through the video when you know that you're going to be stopping to take measurements very frequently. It just, play around with it, and it tends to be more convenient. So those are all the main playback controls up here, and then we have on this lower row advanced playback controls that allow you to do all of the same things really, but at different rates, like this one, and you can set the rates in these little boxes here. So play at rate 0.33, that's slow motion, so we're going to play slow motion while pressed right there. This one is rate 2, so that's going to be a fast forward. So there we got the fish going a little bit faster. A lot of times when I'm doing an analysis, I'll play at a rate of about 2 because it plays very smoothly. If you try and go up to 4 or 8, it tends to get kind of jumpy. I can show that quick here. You see it's fast, but it really jumps around. It's not smooth motion, so you can't really tell everything that's going on, and you're going to miss things in a lot of analyses. If you're just looking for presence or absence of fish, then playing at that rate of 8 might be great for other types of studies where you're looking at a blank screen most of the time and just want to stop when a fish comes on. But for what we're doing with foraging behavior, a rate of 2 is about as high as you probably want to go to avoid missing things. You can also set these buttons, like the 2 play buttons over here, to play at that rate until stopped, which means you can play until you actually hit the pause button, or you can play for an exact duration. So there we set it to play for 5 seconds, and after 5 seconds of footage, it stops after 2.5 seconds because we're going at fast forward, but you get the idea. And then you can play for a random duration too if you want to have like a randomized sampling scheme for when you're measuring something the fish are doing, which is not something we're going to do for this project, but it's good to know about in the program. Any questions about the playback controls?
Bookmarks?
I'll go over that, I guess, now too. The other thing is, so there's the stepping frame by frame over here on the left, and then over here on the right there's a customizable stepping button. So you can step, it's set now to 10 frames, or you can set it to 10 seconds, and it'll jump around 10 seconds at a time, or 10 minutes. That's pretty handy. Like for the paper that I did, that I just submitted, that is about the methods for this thing, I was doing 2.5-minute intervals where I would measure the positions of all the fish on the screen every 2.5 minutes. So I set the frame stepper button to 2.5 minutes, and I would go to 2.5 minutes and measure all the fish on the screen and jump ahead another 2.5 and measure them all. So that's a good way to jump around. Again, it's not a part of the main protocol that we're using for this study, but it's useful to know. And these temporary bookmarks are just a very quick way to mark things that you might want to come back to later. The one on the left there that looks kind of like a bookmark is to set the bookmark, and then the little arrow on the right is to go to it. So in this case, we're going to a temporary bookmark that I set where we've got the calibration frame in view, just to find that part of the video.
Two bookmarks?
Yeah, there are 2 temporary bookmarks, so that you can find, like, for example, 2 potentially good calibration frames that you might want to use and just swap between them rapidly to see which one looks better.
One thing I always kept doing was hitting I would set a bookmark, then I would hit it again, so it would erase it.
Oh,
and
yeah,
set
just by
it
accident.
somewhere else. Yeah.
Yeah.
So just gotta be careful of that.
Yeah, good point. So, all right, that's a pretty complete look at the playback controls. So now we're going to actually try and find. We're going to start out doing the checkerboard part of the calibration.
So I've actually never seen any VidSync stuff before. So is there like a outline, a roadmap you can kind of give us for what the sort of basic steps are going to be that you're going to kind of take us through?
I've got some things like that on the VidSync website that people can go over, but the basic roadmap is you load up the videos, synchronize them, then do the checkerboard calibration, which is to correct for radial distortion, and then you do the calibration with the frame that we've got on screen right now to get the 3D coordinate system put in. Then we're going to load the what are called VidSync types, which are kind of the categories that you set up for your measurements that indicate what kinds of measurements you're taking and how they're going to display on the screen. And there's an automatic set of VidSync types that you can load and use just by default in the program, just kind of as an example, really, and then people can easily customize those for their own study. And then we can actually begin measuring fish.
So it would be really good if somebody wrote down what you just said, and if we had a written protocol.
We've got that
as
on
well
the
as-
VidSync website. So,
Okay,
and I'm
all
going to
right.
have a written protocol for specifically what we're doing for our study as well, which is a useful thing for anybody using VidSync to do when they're working with multiple people on the
Right.
project. So yeah, the website has kind of a general introduction to the steps that people need to go through, and then we'll have our own protocol for study specific steps. But okay, so now here's the distortion correction checkerboard. We'll go through this at a double speed to see. You can see we've got some pretty bold grayling down there, feeding right below. I think that might have been a good frame over there.
Not close to
Right. So for this part of the calibration, and this is something that hopefully I'm going to have some help with here from one or two of you on the project to calibrate some of these videos. We're looking for a frame where we've got a good shot where the checkerboard fills the screen completely or very close to it, is more or less kind of vertically and horizontally aligned, not just totally crooked. A little bit of crookedness is fine, but a lot is not ideal. And also you want to find somewhere that it is being held not perfectly still, but still enough at least that the corners look nice and sharp. And this is a pretty good one.
What is
for
that
this.
window that you've got on the side that's showing zoomed in?
Oh yeah, that's the magnified preview, and you'll kind of see the purpose of that a little bit better later on. So now the next step is to actually digitize the information about the lines on this checkerboard. The basic principle of it is that we're doing this to correct for radial distortion, which you can see really well with the checkerboard on there, right? That we've got kind of a fisheye lens effect where the whole image is bulging, and that doesn't work at all for the 3D geometry. So we have to be able to correct for it. And it's too computationally intensive and difficult and messy to actually correct the video images at some point and straighten that all out. So instead what we do is just calculate a correction factor that works behind the scenes on the distorted image. And that's what we're about to do this for. So the first step in this process is to arrange the straight lines along the checkerboard into actually measured straight lines that we can work with mathematically. And VidSync has this feature, the button for it is the one that says auto here above the list of plumb lines. So we're going to click on that, and we're just going to go with the default settings for now and hit auto detect plumb lines and see how that works.
So do you have to correct
pretty
for
good.
minor differences between each lens, like within lens differences? or between lens differences?
Each one is corrected separately.
Okay.
So, yeah, we do the left and the right camera separately, and we do it pretty much for every individual video too, because there might be slight differences in distortion based on either the camera settings that we're using, or the way the lens is zoomed, or the way the lens is sitting in the housing or something. It's just good to have a fresh distortion correction for every video. Now that auto detection worked almost perfectly.
So are you looking at
So-
the green lines or the red lines?
You're looking at the green line, so I'll explain what all of these things are. There are red dots here that indicate the chessboard corners that are actually used as a part of one of the lines, or two of the lines if it's crossing through them. Yellow dots are other things that the computer vision algorithm from a package called OpenCV detected as chessboard corners. Obviously, they're not all corners, so it's a little bit oversensitive on that, which is fine, because usually if you don't have any false positives, then you're missing some of the real corners too. What you don't want to have is like the screen just littered with those yellow dots. It means you're being way too sensitive to corners, and you're probably going to have trouble picking the real ones out. But in this case, the algorithm within VidSync that picks out the real corners and arranges them into lines had no problem figuring out the real ones. And if you were to have some bad detections somewhere,
So, excuse me for a minute,
yeah.
but so you say it did a really good job because the red dots are actually at the corners of most of the squares.
it's because the red dots are at the corners of the squares, and because all of the green lines that you see here are really following straight lines
Sides
on the
of a-
chessboard.
okay.
Sometimes if you've got a lot of false positives, what'll happen is that it gets confused, and one of those green lines will go straight for a while and then veer off in the wrong direction because it follows a false positive lead somewhere.
Okay.
And sometimes it will detect a false positive off near the edge of the screen that's not actually a chessboard corner, and you want to go through and delete that. And anytime you get one of those bad points, you can click on it by right-clicking on the screen close to it. Anytime you right-click on the screen here on this screen, it's going to select the closest chessboard point, like the closest one of those red dots that it detected. So I right-click near that one, and it selects that, and you see the selection indicator is that kind of yellow crosshairs over it on the video. That's the case for both calibration stuff and later on measurements. And you see, anytime I select something, it also jumps this magnified preview directly to the point that we selected. And you can see that when you do that, it gives you like a much finer close-up view of exactly what we got. So you see over here on the preview that we've really nailed all of these chessboard corners. So the algorithm did a really good job on this frame.
So let's say they didn't line up. Mm-hmm. You manually drag them into the right place?
Yeah, there are a couple things you can do. I'll just mess one up here to show you. We can. So I right-clicked on that one. You can't click and drag them with the mouse, but you can move them around with the arrow keys. So I'm pressing the arrow keys up, down, left, right
Where
right
are you
now.
at on the screen?
Look at the magnified preview.
Oh, okay.
How we're moving the position around. So I just moved it away, and now I'm going to move it back. You can also use the delete key just to completely delete one of those points. If it just puts a point somewhere that there's no chessboard corner and it's not supposed to be there, you can just hit delete, and it'll keep the line, but it'll remove the point.
Do you need to count to make sure there's a dot for every corner?
No, you don't. You can skip a lot of corners, and you can see there probably are some corners in this image that were skipped. Yeah, like, that one down there was skipped, and that's just fine. The point is you need to have quite a few, at least a couple dozen good lines that are pretty well distributed throughout the image.
So green lines we're talking
Good
about.
green
now.
lines, yeah.
And nobody here's red-green colorblind, I hope.
Yeah, you can change the colors of these lines in VidSync settings.
Oh, that's cool.
I did have a postdoc who was red-green colorblind at one point.
Do you not
Yeah.
need to delete those yellow dots that are in the middle of the squares?
No, you don't. The yellow dots are just sort of diagnostic to tell you what the algorithm saw as chessboard corners. And the yellow dots show all the ones that were not turned into red dots by VidSync.
Oh.
One other thing we can do with this magnified preview, by the way, there are a couple different options for what shows what you're measuring. There's that reticle that's like a crosshairs type thing, and then there's also just a dot. I'm going to switch it over to a dot now. That tends to be a little bit easier to use, especially when you're doing measurements, because it doesn't block so much of what you're seeing on the screen, but you can do whatever you prefer when you're working here.
Can you change the color of that?
You can, yeah.
Okay.
It's in the preview settings. There's a little field there to choose preview dot versus preview reticle. You can also change the magnification there. So I might drop the magnification down to 2.5, for example. And then there are some exposure adjustments and stuff. There used to be even more settings there, but then they started in, I think, the latest OS X version, kind of invalidated some of the other settings that we had for the magnified preview, and it was never very efficient to use those anyway. So, alright, back to the calibration now. So these lines are in great shape because the green lines are all tracing real straight lines along the checkerboard, and there aren't any stray points that deviate from that. So now we're just going to go to hit this calculate button to calculate the distortion parameters. And that changes, we used to see the green lines, and now we see these instead, from the red dots, you see a purple line that shows where that red dot position is kind of reprojected to in the undistorted screen coordinates.
Oh, it's like the z-axis.
Yeah.
So,
Well, it shows how much it was from flat.
yeah,
Distance from flat.
yeah, it shows moving it into like a flat projection there, and then the blue lines show that kind of flat projection now of what we've got. And so you see when all of these blue lines look like they're pretty much perfectly parallel and perfectly straight, that's when you know that you've got a really good distortion correction. And this little yellow cross here is the center of distortion, that it's kind of calculating everything around radially. And it's good to see that somewhere near the center of the image. It actually will be a little bit off center in different places depending on how the cameras are set up. So it doesn't need to be perfectly centered, and actually the point of measuring it is to kind of empirically figure out what the center is.
Is there a way to empirically measure whether or not that 2D grid is correct? Like, can the program tell you, you're this much from being at 90-degree angles or whatever?
They don't have to be at perfect 90-degree angles necessarily. It's
I just
you
wonder how
basically just have
important
to
it is,
you basically just have to eyeball it as to whether or not they look really straight. The algorithm itself internally gets as close as it can to perfectly straightening everything out. So as long as you've got reasonably good input data, you're going to get a pretty good output. And if the lines look straight visually, then the distortion correction is pretty
And if
good.
they're not, you go back and adjust your red dots.
Yeah. Yeah, you can go back and sometimes, if you're in a hurry, you'll only get like maybe half of the lines that you want on the screen, and you'll try it, and then the distortion correction looks kind of funny, and then you go back and either adjust them or even find a different frame with a different view of the checkerboard.
Okay.
And like more of a straight-on ideal view, and just try it again.
And so, I don't know if you mentioned this or not, but the green lines automatically map through the red dots,
Yeah.
so you can't move the green lines manually.
Yeah, you can only move them by
Moving the red dots. Okay.
And really the red dots are what matter to the calculation. The green dots are just a visual indicator of
okay. Okay, cool.
how the red dots are arranged into lines.
The green line.
The green lines, yeah, sorry. So, all right, now that was a really good frame for the left camera, but it's not quite an ideal straight-on view. It's pretty close to a good straight-on view for the right camera, but it's not perfect. So let's see if we've got a little bit
so they
better
don't have
one.
to be synced at the same moment.
This calibration.
For this step of the calibration, for the distortion correction version, they don't have to be at the same moment.
Okay.
For the later calibration thing, they do have to be at the same moment for the 3D part.
Okay.
So now we've got a really great kind of square straight on view in the right camera. Even though there's a little bit in the far corners here that isn't shown, I think this is probably a pretty good frame. So we're going to go ahead and try to auto detect now for the right screen. And there we go. Yeah, this, okay, well, here we go. Yeah, we can demonstrate what I mean about false detection. So yeah, this is really good for instruction because this one is almost perfect, but you see down here in the bottom left corner, we've got a couple where it read the very bottom of the whole frame, like where the white
Right.
kind of combines
Same
with the
thing on the
stream
opposite
bottom
side.
there.
Yeah. Because it read
yeah.
the dark substrate as the next square.
Yeah, and it, you see over here, it detected some of those, like the chessboard detection detected some of those, but the algorithm in VidSync to arrange them into lines didn't extend out and catch those.
Oh, that's cool.
So they're kind of two steps against having false readings there,
Okay.
and the second step caught that one, but it didn't catch these because that one, if you're following this green line right here,
It lines up.
you see that it lines up really well, so it looks to the algorithm like it's another checkerboard. So I'm just right clicking there by that red dot and hitting the delete key, and it disappears. And there we're back to a really good chessboard. So now we're going to hit calculate again to get the parameters. Again, perfectly straightened everything out. It won't always look that nice and clean, and that's
So it
fine. This
wasn't-
is about as good as it ever
So
looks.
there were a few yellow lines. There were a few corners that it didn't catch,
Right.
so that wasn't important.
That's fine, yeah. We can go back and switch the visible overlays to the uncorrected ones to see, and yeah, there's, especially off in the corners, there can be things that it doesn't catch, and it's just fine if you miss a few. And sometimes when you don't have such perfect lighting, you're going to miss a fairly large number of them. Like when you're in direct sunlight and there are ripples in the water and it's like bright and dark all over the thing, you want to try and avoid that sort of lighting in the field, but sometimes it's unavoidable, and you can usually still get a pretty good calibration out of it.
It'd be good at some point later, if not now, to look at a video that you think is like at the edge of being not.
Yeah, we can
able
look at
to-
some others. I mean, I've got several that are already calibrated and halfway through the analysis.
Yeah.
So we can definitely look at some other cases later on. But anyway, now we're all set on the lens distortion. And we're going to go over now to the calibration frame input part of things.
So did you have to enter anything to lock the auto detect result in there?
No, it's automatic that once you detect things, they're locked into the program. They show up in
Okay.
these tables, which are the actual distortion correction data.
It auto updates when you delete things.
I mean, the thing that kind of makes it usable to the rest of the program later on, that kind of finalizes this step, is to hit that calculate button that shows you what all the squared lines straighten out, and it fills in these little boxes here that show the parameters for the distortion model, which is
Okay.
described in the manuscript about the methods.
So let's say we didn't have a good auto detect and we had to fool with it a lot. How does it know when you're done?
You decide when you're done. Like when you're done fooling with it, you try calculate
You hit
again and see if
calculate,
see
okay.
if it works well. So
Okay.
And look at see if they look square. The grid.
Right,
right,
the red,
yeah,
the red
Uh-huh.
and green.
yeah.
Okay.
So, and then if you were to do an auto detect, and sometimes you do an auto detect on a fairly poor checkerboard, and things just go haywire. You've got these green lines scattered all over the
Looks like
screen
that one, but that's not
in a
synced
bunch
up.
of different points.
Because that one
And-
looks bad because it's out of sync now because you
Yeah,
moved it.
exactly. Yeah, so it shows the distortion correction grid no matter where you are. When you're on this tab, it'll show that grid.
But that's a good
So
example
you know
where-
we can jump
yeah.
all the way over here. There you go. You can see the grid over the fish.
Yeah.
And if you were to get just a terrible set of distortion lines and you want to start over, there's a button down here at the bottom, Erase All Plumb Lines, on the auto detect screen, which is your best friend when everything just goes haywire and you want to redo it.
Okay.
Otherwise, if you go to auto detect without erasing everything, it'll just add to the bad
It'll
ones.
just
The
double
new
up.
ones, yeah, it'll double up, and you don't want to do that. So that erase all is the way to go. And when you're having trouble getting good distortion parameters, there are all of these different boxes here with different quality parameters, and I'm definitely not going to go into how to tinker with all of those for now. Usually the default settings work fine. The VidSync website has details on how to tweak those if people are having trouble getting good automatic distortions. So anyway, enough about the distortion correction. Now we're going to go to the main calibration. We're going to jump over here to our bookmark that kind of shows we've got this, and that's, yeah, that was a pretty good shot of it right there.
So it doesn't have to be square.
Doesn't have to be square. You just want to see a large number of points on both screens, and not necessarily a huge number. You don't have to see the entire thing, for sure. And in fact, a lot of times when you want to have the cameras fairly far apart from one another, on the physical setup, then you want to have a calibration frame that is so wide that you usually won't see the entire front surface in both cameras, because it's all part of the same coordinate system, and you're just going to be measuring different points. Like you'll be measuring kind of the left half of it with the left camera and the right half of it in the right camera, but we're going to tell it what the coordinates of all of these points are, and it's going to be able to kind of sync it all up into that same common 3D system defined by the physical frame out there. So that'll be a little bit easier to explain once we actually get started on it. So the criterion for figuring out what frame to do this in is that you need good views in both cameras at the same time, and ideally you want the frame to be pretty much still or not moving very much, so as slow as you can get it, and where we can place it on the ground here, that's really ideal. These dots are not moving at all between frames. There's a sort of error called motion parallax from the slightly imperfect synchronization that's off by 1/60th of a second or whatever, where every measurement is going to be a little bit affected by that, by the distance that something moved in 1/60th of a second. Is going to be how far off the measurement may be. So for the calibration, any of those sorts of errors are going to be kind of propagated throughout all the rest of the video. So you want to have the calibration as accurate as possible, and that means having it as still as you can. It's not always possible if somebody's like underwater with divers or something and they're trying to hold it, and you just can't get it perfectly still like we can holding it against a stream bottom. But when we're looking for a good calibration frame in our videos, look for one where it's very, very still or close to it. And we've got a really good frame for that here. So the next step is to click Use Current Frame for calibration. That just sets this, it's kind of like the bookmark feature, except it's for the calibration, and you can only input calibration points on that calibration frame. And now we can jump to anywhere else in the video and use the Go to Calibration Frame button there to jump right back.
What are there's calibration and then the radial, what's the other?
It's the distortion correction.
Okay, so
they're both kind of types of calibration, but the thing I mostly refer to as calibration is the 3D calibration.
Okay.
So don't we have to line up the dots here manually?
Yeah, we're going to have to enter these in manually. And I'm going to show how to do that or get started on it, and then we're going to cheat and load dots that I already did, because it takes not a long time, but like 10 or 15 minutes of sitting here clicking, and it's
It's like a cooking show.
not the most fun thing for a
we
tutorial.
I remember we did that at your house. So.
Yeah, it just takes a little while. So I'm going to show you guys how to do it from scratch, which we'll have to do on some of the other videos, and then we'll just load this one in the form that it's already done. So we're going to, over here is a little box where we actually enter the physical coordinates of the points on each surface of that frame, and in our case we're going to load them from a file because I've already written up that description. It's the calibration frame large.vidsync quadrat file. Hit open, And there we've got these points. So 0, 0 is going to be the bottom left point on the frame, like this one, and then 100, 0 is over here. So these are all in millimeters, and then 200, 0, and 300, 0, and 0, 100 is up there, and so on. So this list just has all of the coordinates that are physically on the frame. And then this one has all the coordinates that are physically on the frame in the back. And it says the Y coordinate is 570. So it says that the back frame is 570 millimeters behind the front one. And these are all of the coordinates that are available in the back frame.
So when you do this, is it always going to save those coordinates as a separate file, or is it saved within this
It
interface?
saves within the VidSync interface, within the VidSync file.
Okay.
You can also export it, so there's a Save to File button here separately just for the coordinates. So generally when somebody starts a project, they're only going to be using one of these frames. So they only enter these coordinates one time, and then they save to file. And then every time they analyze a new video shot with the same frame, they load from file like we just did, and they have that same description of the coordinates.
So you have to save it as a file and then load it when you shift to a new frame.
Yeah.
Okay.
So now we're going to hit set frame and begin calibration. And what that does is it transfers all these points from that table over to this table, where it's got X and Z, which are the real world coordinates, and then screen X and screen Y, which are the horizontal and vertical coordinates on the screen. And now it's just the manual process of going through and clicking on each of these.
And you're using that side window to see that.
You're using the side window to see where you're lined up, and generally what I'll do is have my left hand on the arrow keys on the keyboard and the right hand on the mouse, and I'll go through and click pretty close, but it's never quite exactly where I want it usually with the mouse. So you click and then tweak it with the arrow keys like that. And there's another little shortcut that we can do on specifically for the calibration frames that use these checkered dots, because we've got this computer vision algorithm built into the program to detect chessboard corners. You can hold down the command button and click, and it just automatically jumped to the center of that chessboard. So that's really handy. It usually only works on really nice clear images of a chessboard corner, so for some of them you'll have to do it manually anyway, and the auto detect will get a little confused.
So as long as your mouse is in that circle, when you click, it should grab it.
You want to get kind of near the center.
Okay.
If you're over here somewhere, it'll probably detect a corner off toward the edge or something. So you want to be ballpark near the middle, and then hold down command and click, and usually it'll go to the right place.
Okay.
And now here's a problem that you face all the time, which is that there's a point that's off screen. So what you're going to do is delete that point altogether. There are two types of deletion here. So to delete a point altogether, that's going to be 400, 0 that's missing. So to just get rid of it from the list, you have to click on it in the list and then hit the delete node button.
Wait, how'd you know that was 400, 0?
Because it's 0, 100, 0, 200, 0, 300, 0.
Okay.
Next one's 4, 5, 6. So 400, 500, and 600 are all missing off the bottom of the screen here. So we're going to just hit the delete node button 3 times to delete those from the list. And the next one that we can actually see is 700, 0, which is right there. And 800. And now for the next one, let's say, oops, I clicked over here, and it's supposed to be way down here. So to delete something like that, you don't actually want to delete the point from the list, because you do want to enter something for that point, but you just entered it wrong, and you don't want to have to hit the little arrow keys to nudge it all the way across the screen. That'd take like a minute or 2 or 3. So you just hit the delete key on the keyboard with that point selected, and now it stays in the list, but it deleted the part that you added to the screen. So now I can click over here, and that's going to be 900, 0, put it where I want it. And now the next point on the list is 1000, 0. So there's one entire column of points over here off screen on the right. So you have to be careful about that. And we're going to go through and delete that one. And now we're back over to the next row, which begins at 100, or 0, 100. So
It doesn't matter if you get the same points from each camera, does it?
Right. Yeah, you can use different. You generally will get different points in different cameras.
Okay.
So we're gonna command click these, and you see it goes pretty fast when you've got the ones that auto detect well. You just have to always watch that preview screen to make sure that it's auto detecting correctly. Like there is one that for whatever reason didn't. Oh, actually, that one did auto detect correctly, but then I kind of moved the mouse and it looked like it didn't. Okay, that one actually did not auto detect well, so that's where it is. It's a little bit off center, so they're, half a second to nudge it into the right position. And now the 900 row and the 1000 row are both off screen, or columns rather, are both off screen there. So we delete 2 nodes, come back over here, and start the next one. And you get the idea for the front surface. Now we can do the back surface.
You do the whole front surface
You do the whole
first.
front surface first,
Okay.
yeah. But we're just going to, for the tutorial purposes, skip the rest of the front surface and go to the back surface here. You notice the back surface doesn't even have the same points available because you're going to see the entire back surface usually in both cameras, so we didn't need quite as many points on it. So this one goes horizontally every 200 millimeters instead of every 100 millimeters. So the first one is 0, 0, which is kind of hidden behind the adhesive for that front point. So we're going to skip that one because we can't see it. One important principle in VidSync is that if you can't see a calibration point, don't just try and guess where it is or infer where it is. And just don't use it, because the system, kind of based on the other points, would automatically interpolate or extrapolate the best possible guess at a point that you can't see well. So you never want to just visually guess where it is.
So it's okay that you've got the outer glass point selected and the inner one not selected, because it will use an algorithm to figure out where it's supposed to be.
I guess I'm not quite sure what you're asking there.
So you've got the outer point clicked, but you can't click
right.
the inner point. So what does that mean?
That's just where the selection indicator is right now. That's going to change once we enter a new point.
I just mean this bottom left is clicked, but you can't click that one because you can't see it.
Right, yeah.
You mean front and back?
Yeah, so the front and back, don't have to correspond to each other necessarily. So you can have different points between the front and the back and different points between the cameras. All that really matters is that you have enough points on every surface in every camera. They can be a totally different set of points.
What is enough?
The bare minimum is, I think, 4. Actually, I forget. It's in the paper. It might be something like 8. Generally, you want to go for at least 10, if not, 20 or 30.
That's 10 pairs.
Well, at least 10 on each surface in each camera.
Okay.
And, I usually aim for 15 or 20 or 30. Sometimes we've had videos where we could only get something like 8 or 10 because we're working in really shallow water and you can only see the bottom 1 or 2 rows of points. And the calibration still seemed to work okay in that case. We'll only really have that problem in our Pangini Creek data sites. So anyway, we're gonna delete that point that we can't see, the 0, 0 on the back surface with the delete point button. We can kind of see the 200 0 there. There's the 400 0 and so on, kind of the same way that we did the front. One thing you'll notice is it's putting the 3D coordinates alongside all of these points so that you can make sure that you're lining things up correctly. And it's got the X and Z are kind of the horizontal and vertical. So we've got like the 400 0 point is over here for X and Z, and then it also in the middle shows the Y coordinate, which is between the front surface and the back surface. So all the front surface points have a Y coordinate of 0, all the back surface points have a Y coordinate of 570 in this case, because it's 570 millimeters behind the front surface.
And so you have to make sure you go in order when you're clicking through these, right?
Yeah, you have to go in the order that they're listed over here on the left, because whenever you click on a new point, what it's going to do is add those screen coordinates to the highest point on this list that has screen coordinates of 0, 0. So it's going to kind of fill in the next one on the list, whatever that happens to be.
So you have to do the front pane first, and then click back to the beginning on that screen, and then start the back pane.
Yeah.
Okay.
And you have to delete them. You have to delete the note anytime, or delete the point anytime you can't use that one. You can't just
Yeah.
use the next one.
Yeah. Yeah, you delete the point from the list if you can't see it well.
Because if you just move to the next one without doing that, it'll it'll assign. It'll think that that point is the previous one.
Yeah. Yep. So, any other questions about calibration here? I've got one more step to be done here, which is the refraction correction. And this is for this type of calibration frame design where you've got a clear surface of, in this case, polycarbonate that we're looking through toward the back surface. And the reason we have to do this is that actually the positions of those back surface points are all distorted a little bit from what they would be if you weren't looking through that front face, because the light refracts a little bit as it passes through that quarter millimeter thick polycarbonate, and it's only by a millimeter or two, but it's in effect like it magnifies the image of the entire back face to the tune of 1 or 2 millimeters in a way that is not present when you're actually measuring fish, because you're not looking through a polycarbonate face when you're measuring fish. So we have to account for that. And VidSync does this pretty much automatically. You click this box that says correct refraction for this clip. You enter in the thickness. The default was for something in meters. In this case, it's going to be 6.35 because we're working in millimeters, and we've got a quarter inch thick polycarbonate, which comes out to 6.35 millimeters. You enter the refractive index for the material. That can be looked up online pretty easily. In our case, it's polycarbonate, which the value is listed right here as 1.585, and I think that's actually the default. And freshwater is 1.335 refractive index. So you've got all of those, and now VidSync is going to automatically correct for that little bit of refraction effect.
Can you set that as a default so every time you open VidSync, because for us it's always going to be the same,
Yeah.
right?
Yeah, I think it probably is going to be if there are a few different ways that VidSync handles those sorts of things, but in this case, probably once you use that on that computer, that's going to be the default
Okay.
for new projects. But
Because it's not going to change, right, for us?
yeah, it's not going to change for us.
Except for when we do the tank experiments.
So
Yeah,
now,
it's-
didn't you change the distance on the two? I thought we had a conversation where you decreased the distance between the front and back frames in later trips.
Yes, later on we did, and that is going to be something that we will probably. We can either do that manually, so that would be changing this Y value from 570 millimeters to 200 millimeters, because later on in the season we realized that we could actually get better accuracy by moving that back face in quite a bit closer so that it takes up a larger portion of the screen. And that's going to be something people will have to keep in mind when processing the later videos where we used the back face at 200 millimeters. And it'll be pretty obvious when that's the case, but you definitely want to make sure to do that in the calibration, or else the measurements are going to come out completely screwy, and that's even going to be kind of obvious because you're going to have just crazy measurements showing up everywhere.
Plus, it'll look really different when you're looking at it.
Yeah, it'll be obvious visually, but you just have to remember to change the number too in those cases. Okay, so this is the part where we decided it's too boring to go through and redo all of this calibration, so I'm going to load the one that I did previously. In this case, it's the import existing 3D calibration here, and these are separately imported and exported for both the left and the right camera. Into the folder for it. So here's the left camera file. They're saved as VidSync calibration files. This is going to actually set to a different calibration time, so we might jump to a little bit. Actually, I think I did use the same frame because it is a pretty good one.
That looks lined up, yeah.
Yep, and now we're gonna, you see that jumped over to this screen of calibration results too. This is what you would see if you had actually gone through and clicked on everything. You would then click calculate calibration for this clip, and it would take you to this results page. But we just imported one, and it takes us to the results page for the imported one. If you had done one that you wanted to share with another video that was shot with the same optical parameters, which is what Eric does all the time, right? Because you've got the same exact parameters and the same optical setup in the lab, then you would go to export 3D calibration for the first one that you do. And actually, yeah, you're going to need to know this too, because you're going to be sharing most of them. And then for the ones where you had the GoPro zoomed out, you're going to have to do a new calibration for that camera. And you can do it just for one of them and then import it for the other ones that were zoomed out the same way. So you do the export 3D calibration and then you can import it like I just did. So, all right, that was the left camera. Now I'm going to go to the right camera and import the right camera one. Okay. Problem solved there. I'm just going to double check. I might have forgotten. Yeah, I forgot to do the refraction correction when I initially calibrated this one. So we'll do that quick. Let's see, 6.35. And 1.585, which is the default. And that's close enough. So yeah, I'm just going to change it to the 6.35 there. Also this one. Refraction correction, check the box to correct it, 6.35 millimeters. And now that I changed some calibration related setting, I'm going to go through and recalculate the calibration, and it's going to be just slightly different than it was before. And I'm going to do that for both cameras separately since I changed that refraction correction, and it's going to be just a very minor change to these matrices, but it helps a little bit with accuracy in the long term.
You can also see which points, like on the back, well, you could a second ago, which ones he didn't use.
All right, and I just accidentally hit Command Q instead of Command S, which quit the program, which is fine. Or we're gonna go open it up and reopen where we just were, and there we go.
How did you get those grid lines to disappear again?
So it loaded by default on the lens distortion calibration tab, and whenever you're on the lens distortion tab, you'll see those grid lines if they exist.
Oh.
So now we just went to the 3D frame input tab, and it shows those frame points, and you can see the results there. So we're all set.
So right here are ones that, especially in magnification, it looks like you probably could do. The fact that you didn't do them makes me think that we've got plenty of points that we know for sure, and we let the interpolation do its work on the rest.
Yeah, so like you're talking about these two right here.
Exactly, yeah.
And if you look closely, you see those are
Foggy.
yeah, this was
I think
this
the
was
frame
early in the
fogged
season,
up or
and I think
something.
we had I think I had forgotten to remove some of the clear acrylic, or not acrylic,
The plastic paper.
some of the clear like plastic paper type stuff that we had stuck on the front here. You see, like over the 2040, there's like a little square of that semi-clear plastic. So when we first built the calibration frame, we were thinking maybe you could actually see through the clear plastic all the way to the back frame. And it turns out that even though it's clear, it totally obscures your view of what's behind it. So we had to cut it out. and I think we cut it out and forgot to remove one or two of the squares of it, and that's what you're seeing right here as you're looking through that
Right,
clear
but-
plastic, and it blurs everything to where you really can't see exactly where the center of that is. You can roughly guess, but the computer can better roughly guess
Right,
by
so-
interpolating.
So that's the point I'm
Extrapolating.
trying to
Yeah.
make for these guys that are going to do it, and it just kind of reinforces what you said earlier about having 10 points or
Yeah,
15
exactly.
points being sufficient. You guys only want to be measuring ones you're absolutely sure of.
Exactly.
The computer guesses better than you.
Yeah.
Yep. Yeah, that's the bottom line. So, all right, now we're calibrated, and we can go on to the measurement tab. And one other thing I'm going to do here is expand that screen. The default when you open up a project is that this control bar is only taking up a portion of the screen, and you can hit that little plus icon in the top left to make it stretch all the way across the top. And that's really convenient to do because then it's a little bit less sensitive and you've got a little bit more control. In this scrubber, you've just got, it's like a longer bar. So you can have more fine control over the time jumping around that way. So let's see where that main fish that we want to measure comes in. Okay, so there he is, and I don't know. You want to start the analysis at maybe 15 minutes after that fish came back to its spot. We've got such a long video of this fish. I'm pretty sure we're not going to analyze all of it. So let's just jump to where we're really certain that it's. And here we're at this fish that just came onto the camera within the last minute or so at this point. So we're going to jump ahead 15 minutes to get behavior where it's kind of back into its normal undisturbed thing. Normally we only go with about 5 minutes for that, and that's plenty, but we've got so much extra here we might as well give it some extra time. So now to actually create measurements, we're going to go into the type system in VidSync, which is how we categorize measurements. We've got this window called Object and Event Types, and in all of the files for this project, we're going to load types from File right there and go up to Drift Project Types.VidSync Types and open that. And now you see we've got object types are like grayling, Chinook salmon, Dolly Varden, but also cover boundary if we want to, and we haven't done this yet and probably won't do a lot of it, but there's a type for if we want to measure like the barrier of a log jam kind of behind the fish. River bottom is to measure points along the bottom everywhere so that we know what the depth is and how far the fish is above the bottom. We are going to be doing that. Also river surface. That's going to be a tricky one with this being as deep as it is, but we can do it. And then tracer collection, that's the object type for when we're measuring the couscous. So this is, and then I'll show you quickly what the event types are and then come back to this. So event types are like everything from foraging attempt to length measurement to fish enters view to analysis begins. So they're a mix of like real events in the video and just things that happen that you want to mark somehow. And the distinction between objects and events, really all it is just a hierarchy for your measurements, and you can use it kind of creatively in different ways. It doesn't always have to correspond to real-world objects and real-world events. For example, tracer collection is each individual event that we measure is actually an object. It's going to be a piece of couscous drifting down through the river. But we're not going to want to create an object for each one of those when it's much, much faster to just put them all in the same collection object and then create an event for each one of those pieces of couscous. So there's some flexibility in this system, but this is the basic idea. And the object types define basically, well, the object types define the default color, and then the object
default
itself, the default color for the icons that are going to appear on screen when we make the measurements. And when you actually create an object, you can set the color for that object. So you'll have, like, if you've got 2 or 3 different fish on screen, each one will have a different color. So it's easy to tell the measurements for the different ones apart.
But what else are those
On
different
screen.
things doing besides that?
Mostly they're just an organizational tool for when you're analyzing data.
So like
So that-
folders.
Kind of like folders, but not really. The way that they're stored is, they could be like a column in an Excel output file that VidSync can generate, or we actually export most of the data in an XML file, which I don't know if you're familiar with HTML at all, like how you program a web page, but it's kind of like a hierarchical system of tags where you have like an outer tag for the object and then an inner tag within the object for the different events.
Okay.
I can show you at some point what that
Okay.
looks like, but it's basically just a good way to include a complex set of information in a way that can be read pretty easily into R or Mathematica or MATLAB or Python. I've used all of those with VidSync.
And so you can add your own to these.
You can add your own, yeah.
Oh, I see.
It's
Add
all
new object
it's
type.
all totally custom.
Okay.
So those are the object types, and then the event types define many more different things about your measurements. So most of the stuff that appears on the screen is determined by the event type, like the duration of how long the icon is up there, the size of the marker, the shape of the markers. We have a million different shape options here, or at least 50 or something. Everything from like Pac-Man, which is a foraging attempt, to up arrow to fighter jet. So there's a lot to choose from. And for the most part, these are predefined for our project, so you won't actually need to mess with them very much, if at all. You
want them to
can
be standardized. Yeah.
you can set them to, if you're going to have more than one point on a particular type of measurement, which some of them do, some of them don't. Like, there are a lot of things where you just want to measure one point of something, like you located this type of fish at this point, and that's all you need to know. So that would that you wouldn't have to worry about any of the connecting line stuff down in this area. But for example, for length measurements, what you would do is create a type of event that has 2 points with it, one for the head, one for the tail, and you would tell it, click this little box here that says the label length, and it's going to label the length on that measurement. Or for the velocity tracers, you can tell it to label speed, and it's going to label the speed of that measurement. And this all might look a little bit abstract until we actually go in and start doing some of these measurements, which is what we're going to do right now. So first we're going to create a fish, Arctic grayling, and let's make it bright green. All right, and we can name this grayling after, you don't have to name them, but it can be useful to kind of tell which one is which or remember which one is which, so we can name this grayling after Gary. So that's Gary's grayling.
Is this the one with the bite out of the fin?
Yeah.
Shark bite.
And we are going to so now we added that object, and now that's we have an Arctic grayling object in the list right here. There's this top list is the objects in the project, and then if you select an object, this list shows all of the events for that object, and if you select an event, it will show all of the points that you've measured for that event. So we'll kind of see that hierarchy in action here in a second when we actually add something. So now we're going to add a analysis begins event right here for this grayling, and we're going to click on the nose of the fish, and you see now that we clicked over there, a line pops up over here. That tells us where the thing that we clicked over here has to be, because it's kind of like the left camera image projects a line of sight straight from the left camera through the nose of the fish that we clicked. And, it's just like a single point in the left camera. But as viewed from the other camera, it's a line that you're seeing from the side. And that's what this line over here is.
Oh, cool. So it's the line is shooting from.
It's
left to
shooting
right,
from the other camera, yeah,
across
through the
nose
fish.
of that fish.
Uh-huh.
Okay.
And this is not especially necessary when you've got one big fish on the screen and it's really obvious what's what. But when you are doing like juvenile Chinook salmon and you've got 20 fish on the screen, it can be really hard to tell which one is which in both camera views from different angles, and those lines are lifesavers. So now we're going to click on the other one, and there it filled in that thing. Those things are called hint lines, by the way, and there's a little control over here for them, so you can set it to show all of them or none of them, or just the unpaired ones, which means to only show it when you've got one that's like awaiting the data input from the other video.
So how come you have your windows set up like that for your two videos? Why wouldn't you want to make them so you can see both at the same time?
Because you can see it a little bit bigger this way.
Okay.
See a little bit more detail. That's how I like to do it on this particular computer.
Okay.
You can also blow it up to 100% there, and just you can only see one at a time, but you can use the space bar. If you're over one of the videos, the space bar will cycle you through to the other video, so that's kind of a handy way to switch back and forth there, yeah. And you do kind of see a lot more there, but I find that I can usually see most of what I want to see at 2/3 on this screen. And any finer details that you want to see, you can kind of put the mouse over right over there. And by the way, there are a bunch of keyboard shortcuts. We're not going to go into all of them now, but they're on the VidSync website. And like Command right arrow and Command left arrow are going to step forward or backward a frame. And you can, if you want to like watch something close, like for example, one of the things we're going to look at is in some videos, including probably this one, whether or not the fish spit out something after it grabbed it. And you can watch the mouth really up close in the magnified preview while holding the cursor over it and kind of stepping frame by frame with the arrow keys, using Command and the arrow keys. So, all right, now we lost that point that we were on because I was jumping around a little bit. You gotta go? All right. So the next thing we're going to do is, to get back to it, we just select it in this events menu and click go to point, and that jumped us right back to there. So we'll be able to jump around all over
It's like a
different
bookmark
things.
almost.
Yeah, like a bookmark. And now let's go ahead and watch until this fish grabs a piece of food somewhere. Alright, so there was a foraging maneuver. So the way that we're digitizing things on this one, so I found that foraging maneuver, and then I backed up to before it started, and now I'm using the mouse wheel to find the exact point at which the fish begins to respond to that prey item. And it's a little bit tricky to tell, but I think probably this is the frame right before it begins to move. And we're going to have a protocol that says exactly what to do in these sorts of situations where you're wondering, like, okay, is it that frame or is it that frame? And, that's not a huge difference, but just for consistency to know what we're doing and not doing it randomly different ways, it's going to be kind of the one immediately before the fish makes a perceptible motion into that maneuver. So now we're going to add a foraging attempt maneuver here. Or a foraging attempt event rather. So we went to the add event button and selected a foraging attempt, and now we're going to go click on the nose of the fish right there. You get a little Pac-Man icon for a foraging attempt, and it shows where we want to be in this video too.
So by doing this, you're just essentially collecting data while you're watching this video and adding it to columns of a spreadsheet.
Kind of, yeah.
In a simplified version.
Yeah, that's a simplified way of thinking about it. It's a fancier data structure than a spreadsheet that you can ultimately export into a spreadsheet or something else
Because XML
with a little
is
more complexity.
complicated.
Yeah, XML is
I
more
don't really
complicated.
understand it, but
Yeah, but it lets you preserve a little bit more detail about the relationships between things than a spreadsheet does. And people can go with either method depending on what they're comfortable with, like importing into R and stuff. Because you can import either kind into R, but XML is a little bit more involved. Same with Mathematica and MATLAB and Python and everything else. So, all right, there's the beginning of a foraging attempt, but we've got a foraging attempt now is defined as an event with 2 points, because we've got the point at which the fish begins the maneuver, and now we're frame stepping with the mouse scroll wheel over to the point where its mouth is at kind of the maximum gape, and we go with the first frame of maximum gape if there are kind of 2. So there's where it's just ending its opening, and there is about as wide as it gets, so that's going to be the one. And then we go with the tip of the upper lip right there. And that's a completed foraging maneuver, and now we'll go ahead and watch until it does it again and do another one.
But were you watching for something to make sure it wasn't like it's just a foraging attempt, so it doesn't matter whether it actually ate something or spit it
Yeah,
out?
it doesn't matter whether it actually ate it. It detected something that it wanted to go for. And in fact, it doesn't even matter. Well, we'll probably be recording the difference here, but we're recording them even if the fish goes and looks at something and doesn't grab it, because that's still, for testing our model of prey detection, that's still a valid hit where the fish detected something and went to investigate it. And that's actually what's going on right here.
So this is recording time and distance.
Yeah, it's going to record distance and time, and everything is even going to be put in terms of like natural directions of the stream, which we're going to get into in a second, like upstream, downstream, true vertical direction or true cross stream direction. So here we'll do one more foraging attempt quick. This is going to be one where the fish begins to go after something and then turns back. Yeah, so there you can kind of see, in this case, it's really clear with this big fish because it's looking at it and then its eyes turn away. So and its body begins to turn away too. So that's the frame at which we're going to mark the end of that attempt.
That's a foraging attempt?
Yeah, because it's detected something and it's going in that direction to check it out. So we're going to be, presuming that there was a detection there. And we got a squirrel climbing right behind the computer screen.
It's very exciting.
Too bad we can't turn the screencast camera around. But anyway, so that's how we do a foraging attempt, and it's just a matter of, collecting a couple hundred of those per fish or something like that. We're going to figure out the exact number that we need to get the summary statistics that we want after we've done several of them and kind of see what the data looks like. But that's the idea. Command S to save. By the way, at any point here on any of these things that you see on the screen, you can right click to select them with the little yellow selection indicator, and you can try to nudge them. And I often forget, if the indicator is on screen but you're not actually at the time code when you began that point, then you can't move it around. So you have to go to the right time code, and if you try to nudge it, it'll either give you a prompt to ignore it, like, oops, I hit the arrow key and I didn't mean to, or you can go to the original time code, which we just did right there.
With that little bookmark?
And, yeah.
How'd you do that again?
So I was off on the wrong frame somewhere. Let me do it again. All right, so there I'm on the wrong frame, and I selected this thing, and hit the arrow key to try and nudge it, and then realized, oh yeah, I'm not on the frame where I initiated that measurement. So okay, we'll just click go to original time code, and now we're back there, and now we can move it around.
That's convenient.
Yeah. So there it is, right on the tip of the fish's snout. So, for a lot of these foraging attempts, you can get close enough just kind of eyeballing it with the mouse, and you don't need to mess with it with the arrow key every time like you usually want to do with the calibration. But anyway, so that's a foraging attempt. Let's try and add another event here. We can do some points along the bottom. We're gonna do a surface points, or let's see, no, do we have we should have a river bottom event. I'm trying to remember how I did this. Oh, object type, river bottom. Okay. So we're going to add a river bottom object. Okay, so there's a river bottom object, and we're going to add a surface points event to the river bottom object. And here's...
That sounds kind of confusing.
Yeah, so we're like creating an object that's going to include all the measurements of the river bottom, and then our event is going to be, and we'll like back up away from where the fish was, I guess, to do this too. So we've got this river bottom that's like going to be a collection of measurements, and then the surface points measurement, or the surface point event, is going to be every individual measurement of something on the bottom of the river. So, let's say that rock right there is going to be one of them. So you got a measurement on that rock.
It's confusing because you're saying the surface while you're talking about the bottom.
Yeah, it's like the surface of something, or this.
Okay.
Yeah, it's not the best name for that.
Okay.
So in this case, it's the surface of the bottom of the river, the surface of the rocks, or
Okay, I get it now.
yeah. Okay, and this is a really easy one to do, those points on the bottom, because you can see the same points on a bunch of these different rocks and stuff.
What's the point of this though?
Going to be able to use it to get the depth and see like how far above the bottom the fish are doing all of their maneuvers.
Oh.
And it's a pretty quick step to get that data. We don't need to get every single rock on the bottom or something, just enough to characterize it reasonably well. I'm just trying to sort of, pick easy to identify points in both videos and spread them out, trying to click on, the same rock in each one.
It's. I'm sure it's doing what you're saying it's doing. For me, it's hard to understand how you could actually measure a horizontal axis at this angle. Like a vertical axis, I guess is what I should say.
It's basically triangulation, right?
Yeah, so are you talking about like how are the 3D measurements done in general, or?
So you've created a 3D model, which is why he's able to do this, right?
Yeah.
It's just it's hard for me to understand how you could actually, from like not being perfectly perpendicular at a 90-degree angle, to measure the height just by looking at a certain angle at a rock and measure the height that it's going up, even though because the angle is not perfectly vertical. You know what I'm saying? Because it's tilted down.
Well, this would be, we're not going to measure like the height of the rock, although we could, but we're like the distance between the rocks and the surface. And we're going to have like 3D coordinates for all of these points. So even though everything is not perfectly aligned or parallel or something, we're going to have 3D coordinates of all of this stuff, and we can fit a plane through all of the 3D points on the surface, and then we don't need to fit a plane. We can just average the depth at each one of these points on...
So it's actually, when you click on one camera, it's making the point on the other camera as well? Or you had to put them there yourself?
I have to put it there myself.
Okay.
That gives it the data. Basically, if I click on... Let me find a good one here. Okay. So I'm going to click right there on this rock in the left camera.
Yeah.
And all that tells me in the other camera is that it's going to be somewhere along that line. That's what the hint line is for, is that you click on the point and then it's going to be somewhere on that line in the other one. And in this case, we can recognize just visually that that's the same rock, so it's going to be right there. So I add it manually there. And that's pretty much how that works.
What's the margin of error though in those measurements?
It depends on the specific calibration and the camera optical settings and a whole bunch of other things, but in general, like length measurements, in the test that I did for the paper, the manuscript about VidSync, we were able to get sub-millimeter accuracy on length measurements out to a range of 1 to 2 meters in a system that was calibrated for that. You can do a little bit better at longer range when the system is calibrated for slightly longer range. But in general, within 1% or 2% of the true length of the object is pretty reasonable if the calibration has been done well. I think we've got somewhere we're going to have a little bit lower accuracy than that, using highly distorted fisheye lenses to get a really wide field of view in some of our sites, but it should still be accurate enough to be usable. Alright, so that's more than enough bottom points for us for now, or maybe I'll do one way out there just to extend it a little bit. Let's see where that rock is. Yeah, that's this one right here. There we go. Alright, so we've got a pretty good sense of where the stream bottom is in this area the fish was using. The surface is going to be a little bit trickier, because in this case we don't have anything sticking up through the surface, which is normally the easiest way to find surface points, because it's going to be really hard to identify the same thing on the surface in all
Except
of
for
them.
ripples or something. I saw like a...
Yeah, they're like ripples and bubbles and stuff, and in this case I think there's some sort of black thing drifting on the surface right here that we can get. That's pretty hard to see, just dark piece of moss or algae or something. So we're gonna create now an object called river surface, and it's also gonna have surface points events to it. And let's see, make sure I can find the darn thing. Okay, so that little black whatever it is there, I think, is on the surface.
The only thing I could see that's on the surface is ripples.
Yeah, I'm looking at something really faint, and okay, yeah, I'm pretty sure I got the right thing here. It's right there, and yeah, right there. By the way, one thing to know about those hint lines is that it's kind of like with the calibration. You don't want to use the visual cues to figure out where, like, you don't want to use the line to figure out where to place the point. You want to use the fish or the stuff in the video to figure out where to place the point. The line is just an indicator to tell you where roughly the fish is going to be, and sometimes the line will be a little bit off if there's some kind of issue with the calibration due to what lens is being used or whatever. So you never want to just, click on there and then move it over to the line just to match the line. You want to click as close as you can to the actual physical object, the fish's nose or whatever it is that you're trying to measure, even if it's a little bit off the line, because that's going to get you the closest to the true
Well, if you were just going to go to the
measurement.
exact point on the line, then there's no point even clicking because
Exactly,
the
yeah.
computer's already telling you.
Yep. Okay, there's a nice bright bubble on the surface, so we're going to get that one.
So it doesn't all have to be in the same frame.
Right, yeah, the surface points can be in different frames. I didn't do them in the same frame for the bottom, or I did them all in the same frame for the bottom just because the bottom isn't moving around a whole lot. But for the surface, it's pretty common to have to do that. There's a big piece of something that I'm pretty sure is on the surface, yeah. Okay, so there now we've got 3 surface points. That's enough to roughly get the coordinates that you need. Normally we want to do at least 10 to average and kind of, average out there or in any particular point. So we're going to have that in our project-specific protocol, how many of these points you want to get. But 3 is enough for now. I'm going to save that. And now we can go try and find where we threw that couscous as a velocity tracer. I think we're seeing...
Are those not on the surface?
Is that couscous, or no? Those are all bubbles drifting up from after we did the calibration.
Seems like you can see the surface pretty easy in this.
Mm-hmm.
There's bubbles on the surface that are floating along, right? Is that the surface at
Yeah.
the very top?
Uh-huh. Yep. So that would work. By the way, one other thing I forgot to mention when we were doing those measurements, go back here for a second. So like for the river bottom ones, these surface point events are defined as having, in the event type, it's defined as there's being just one measured point, or actually no, you can have, surface points are a bad example because you can actually have lots of measured points per event. So yeah, that's kind of a different style of organization here. So you just got one object and one event, and then a whole bunch of different points at different timescales under that event. It's a different way of handling that hierarchy to make things really convenient. But for example, for the foraging attempts here, to make the point I was going to illustrate a second ago, these foraging attempts are defined as having 2 points per event. And once you've finished the second point, and you want to try and create a new event, that there might have been one where you looked at a bit of prey there, but he didn't make much of a motion for it, so we won't count that one. Okay, so there's a good one. So we're going to add one more here. So I'm basically just showing there's automatic creation of a new event when the event that you have selected on the list over here is one that has a limit to the number of points. Then the next click that you make on the screen is going to automatically create a new event of that type.
So a 2-event click, if you make a third click, it creates a new event.
Exactly.
Okay.
Yeah, kind of a long-winded explanation on my part of that. You have a... So there we go. I just clicked on the screen and it created automatically a new event for
So
this
just click
new
wow.
foraging attempt. Yeah, and you know, basically it just speeds things up a lot.
What happens if you need to delete one?
There's a delete button over there. You can select it from the list of events.
It's not the same way as when you do calibration points where you have to use the delete key on the keyboard?
It kind of is similar actually, because what you can do is it's not going to delete the event or the entire point, but it's going to delete your entry of that point onto that screen and act like you didn't click there yet. So
It'll work the same way then?
yeah, so there I click, and now I'm going to hit the delete key, and the click is gone, and we're back to the hint line.
So then if you were to select it there and then click the delete button.
If I was there, if I was select it here and delete it, yeah, then it would delete that whole foraging attempt maneuver.
Okay. It's kind of doing the same thing, essentially.
Yeah.
Work as far as the way it works. Yeah.
Uh-huh.
Okay.
Yep. And then, yeah, there is some fancier features here, like you can click edit on an event and see some other things. And if you've got other objects involved in the project, you can add them to an event, so you can have more than one object associated with an event. So, you know, we can, silly example, we can see that the river bottom was also involved in that foraging attempt. Of course, the river bottom was not chasing that particular piece of food, but we can say that it was. And where that is really useful is when we've got more than one fish that we're measuring on screen and we're interested in. I'm still not sure if we're going to digitize this or not for our project, but conflicts between fish, where you're tracking multiple individuals and you want to look at the conflicts between them. So you've got two fish that you're tracking that are both involved in one conflict event. Instead of creating separate conflicts for both fish and somehow trying to make a note or something that they're the same one, you just add the conflict event from the other fish to the new fish that it's involved with.
So that would be better if there was situations where it wasn't always just two fish. Is that what you mean? Because normally wouldn't you just be able to make a 3-point event if there was always two fish?
No, if there's a conflict would be just the same event that it is, like 1 or 2 points, depending on how you decide to characterize it. And you would just add both fish objects to that event.
I would just mean, like, let's say that these two grayling right here, this one and that one were going after a piece of food. Wouldn't you just be able to click there, and then the food and make a 3-point object? Is that what we're calling those?
You could create a 3-point event, if you wanted to. And it does, depending on how you want to characterize a conflict, that is kind of a good way to do it, is to, click on both of them and then click on the thing that they're conflicting over. But the thing is that on the list, that's still going to be over here organized. When you create it, it's still going to be associated with just one fish or the other, even if you clicked on the other fish, because you haven't told it that that click on the other fish was the
So
other
you could
fish.
put them together, but you can't separate them if you do it that way. Whereas the way you
yeah.
were talking about doing it, you can always have them together or separate.
Yeah, so, well, the thing is, when you click, the event that you've created is still going to belong to the object that you created it under initially, no matter what. You could be clicking on the surface or a log or the bottom or whatever, but if you click it while you're working on this fish, it's going to think that that's an event of this fish. So if it's the other fish in a conflict, it's still going to think it's an event of this fish for some reason. And if you want to tell it that that's a conflict and that other fish was involved, then you would have to go over to the other fish in this list. And, we could, here, we'll just add a second Arctic grayling. Not that we're necessarily going to analyze it. Test fish. Okay, so now we've got a second Arctic grayling. And let's just go to this foraging attempt and pretend that it's a conflict, even though it's not. And we're going to edit that event and add this Arctic grayling object to that event. So now we've got two fish associated with that one event, and you see the icon for it changed. So instead of having just the one color, now it's got the same icon but in concentric circles, or concentric Pac-Man in this case, with different colors. So that shows that both the light blue fish and the green fish were both involved in that event, if they were, which in this case they were not. Okay, Gary, I hope you don't mind we named the main fish after you.
As long as it's dominant.
It's the 19-incher with the big torn-out fin, so it's the best one here. You got the best fish. I can show you a couple of other quick features of VidSync. So here's the annotation tab. This is where you can make a text note of pretty much anything. Like you just see something interesting, either that you want somebody else to come back and take a look at for like a second review to decide how do I interpret this particular kind of maneuver, or there's just something that will be cool in a presentation. Like, something cool happened here, right? And you can just make a text note on the video.
So is that going to be a bookmark where you...
It's kind of like a bookmark, yeah. The annotation tab is kind of like named permanent bookmarks, whereas the bookmarks over here on this screen are just temporary and they go away every time you close the program.
So that's only going to be there for one frame?
In this case, it's there for 5 seconds and then fades away for 3 more seconds, which is just a default, and that's all set over here.
Okay.
Another thing that's really handy, and we'll delete that one and we'll put a real one in here. We're going to go to the analysis begins point, which I think we're pretty much there, yeah. And now we're going to go to an annotation, and we're going to create one. Let's make it green. We're going to call it analysis elapsed, and we're going to check the box for append timer to the annotation. You can select it and move it around with the arrow keys just like everything else. And now you've got basically a time code over the video that is counted from the moment that we begin the analysis of this fish. So if we're trying to do 10 minutes or 20 minutes or 30 minutes of analysis, we'll know when that time is up. Except that it went away because I forgot to change the duration to 1,000 seconds or something. There we go. So now I'll go back to that, and now we'll see this analysis elapsed annotation is just going to stay up there for the entire time that we're analyzing this fish, or at least for the next 1,000 seconds.
So what were the little green Pac-Mans? It didn't look like it was feeding, or am I just not close enough to see it?
It was, yeah, you're not close enough to see, and it's not...
there were two right adjacent to each other.
Yeah, not each one of them...
Make it the big screen just for that one thing, maybe, so I can see it.
Yeah, let's big screen that. So not each one of the Pac-Men indicates the moment that the fish was actually like intercepting something.
Okay.
And the foraging attempt event is a 2-point event marking the point when the fish begins its maneuver and the point when it terminates the maneuver, either by capturing something or by turning away from a pursuit.
Okay. Yeah, so I mean that's the next thing. You probably already talked about this, but
Yeah. So did
I mean,
you
we need a list of what we're supposed to
Yeah, exactly. That's
supposed to measure.
That's something I've
so-
thought a lot about and worked on a protocol already.
Okay, great.
That I'll be sharing and refining while I'm here.
Go, Gary.
So yeah,
There
so you
could be an attempt to measure, so like when the fish starts to make the maneuver, where that food particle is that it ends up. after.
no, because it's too hard to see the food. It would be great if we
Couldn't,
could, if we had like
backtrace it.
if we had like 4K video or something. So basically, backtracing it is what we're doing. We're inferring based on the water velocity. And the position where the fish intercepted the particle, we're inferring where the particle would have been when the fish detected it, which works
Back of the envelope calculation.
pretty well, I think, when the fish actually intercepts the particle. It's less of a good approximation when the fish cuts off its pursuit, because you don't know exactly where the particle was when the fish terminated its pursuit. We'll just assume it's at the fish's nose position because we don't know any better.
I mean, you could cut off its pursuit because it realized it wasn't going to get there.
Yeah, exactly. So there is a little bit of a bias that's kind of unavoidable, I think, in those cases. So yeah, you see here, there's the Pac-Man when it begins to maneuver,
Okay.
and then the other one when
Takes the
it takes the thing.
Right.
Yep, and now it's coming back down. There it went and just looked at something and turned away. And now we're going to have another one where pretty soon it's going to go for the thing.
That
do you have to
seems
have-
like kind of a judgment call.
It is, yeah. It's kind of unavoidably so. And yeah, there is an infinite degrees of subtlety. It's a very smooth spectrum from what counts as actually maneuvering for something and going after it and turning away, versus just briefly putting their eyes on something and then turning their eyes back upstream, which we're not counting. And then
Yeah.
there are things where you don't know for sure that the fish actually moved its body. So we're looking for a substantial realignment of the fish's body in the direction of some piece of potential prey to count it as the beginning of a foraging attempt, even if the fish doesn't go very far. That's the cutoff.
Did Gary survive a bear attack?
We don't know what took a chunk out of it.
Yeah.
I'm guessing maybe a
otter, maybe.
otter, merganser, or something.
Have to be
Yeah.
a hell of a merganser going after a 19-inch gray leg.
Yeah.
It's a what? It's a
fish-eating duck.
piscivorous duck.
Yeah.
We have them here.
Really?
Yeah,
Oh,
yeah.
okay. What's the common name of those?
Merganser.
Oh, never heard of it.
American merganser. There are like
There's
three
like
or four
hooded
species.
merganser and common merganser are the two that I'm familiar with.
Yeah, there's red-breasted merganser. I think there are 4, but I'm not
Huh.
sure. There may just be
Okay.
I'm
3.
used to anhingas and cormorants.
So
Yeah.
anyway, one thing that's good to point out on the tutorial, and that we might end up doing for some of these, there's this notes field over here on the event screen. So you could just put captured,
Right. Prey capture.
and then
Or
the next one could
Prey
be
turn off. Or,
could be visual
Yeah.
rejection, right? So and in reality, for speed, these are all going to be like 1 or 2 letter abbreviations for things to go into that notes code, and they're all going to be
Yeah.
standardized so that we can read them into Mathematica or something very easily. But we're going to have just like a little printout of VR equals visual rejection. And over here we've got capture and export data tabs that are pretty self-explanatory. Capture is basically for capturing video files with or without all of the fancy overlays. Capturing a video clip without the overlays is really fast. Capturing them with the overlays is really, really, really slow, and there's really no way
One
around
of those
that.
being the Pac-Man and the time code there.
Yeah, so if you wanted to do a 20-minute analysis and then capture the video with all of the overlays, you're going to leave the computer running overnight to do that.
Okay.
if you want to do a 20-minute chunk with no overlays, you click it and it's done a couple seconds later.
So the reason you would do that is just like a video editor, like you're just interested in pulling a piece out to show.
Yeah, you want to pull out a piece to put in a presentation or
Okay.
something, then you use the capture tab for that, or just capture screenshots
Okay.
with the overlays. And then the export data tab is to actually put your 3D measurements out there into. There are a few different options. You can export them as an XML file that, like we talked about, contains all of the hierarchical data about your objects and events that you could possibly want. The CSV file is a spreadsheet that contains as much as can fit into a spreadsheet, but that still leaves some things out just because you can't get quite as complicated of a data structure in there. You can also copy some things to clipboard and then paste them into a spreadsheet, including 3D point measurements or the length measurements and speed measurements of the connecting lines. That's one thing we can show quick, is maybe a connecting line measurement. So we'll do a length measurement on this fish when it gets over here and reorients itself well. The video's decided to misbehave a little bit on us.
Is it trying to sync up or something?
Yeah, I think it's just the hard drives decided to take a little break.
Okay.
Something like that. Alright, so there the body of the fish is pretty straight. So we're gonna add we're gonna add an event, length measurement. Click on the tip of the nose there. Tip of the nose there. And yeah, by the way, this is a good thing to point out. When you're adding an event that has multiple clicks and they're both in the same frame, you don't have to go like left camera, right camera, left camera, right camera. You can do both clicks, head and tail in the left camera, and then go do head and tail in the right camera, which is what I'm doing right now. So it makes that quite a bit faster. There we go, 497 millimeters. So that is a
Just incredible.
big grayling.
I almost don't believe it.
Yeah, that one might be a little bit off. We'll have to check into the calibration on that.
Big Gary.
Yeah.
That's
Ooh.
Did you catch that? You caught that fish.
Yeah, we caught
right?
that one.
So we have an exact length measurement.
We have
to
an exact
compare.
length measurement to compare on many of them, yeah, and a stomach sample. This one,
That
this,
would be
this is probably a,
497 would be a huge grade.
yeah, I think that was probably a little bit too big. We might have to revisit the calibration on this one and see.
That's a good way to measure right there. It's pretty,
Yeah,
pretty flat.
it was.
Yeah. Let's see what
It
we
was
get over
not
here.
perpendicular to the.
Yeah, and it's ideal if they are. They don't have to be exactly, but definitely helps. 470.
That's more like.
That is more reasonable, yeah, so. Yeah, that's a better shot at that grayling for sure.
So I'm certain.
Still a very big fish, and it was a really big fish, so.
So, like when it's going at different angles, have you like done? I'm sure you've done this multiple measurements at different angles
Yeah.
and see how repeatable they
Uh-huh.
are.
Yeah, normally it's pretty good. It gets to be a little bit more difficult with the particular cameras that we're using.
Yeah. What
and
makes it
It's the
worse?
fact that we're using fisheye lenses, I think.
adds more?
They sort of, I think they add a little bit of distance dependence to the radial distortion to be using a true dome port and true fisheye lens on the camera. There's a little bit of optics in there that's not accounted for, not enough to really mess up what we're doing, but it doesn't provide the maximum measurement accuracy compared to a rectilinear lens like I've used before, which is a little bit of a surprise, but it's still very good quality. It's great quality and great field of view, which is really important for what we're doing.
Yeah.
Anyway, let's see what else did I want to show here. Oh, there's velocity tracers, maybe. So we got to find where the couscous is here. I think it's toward the end. Yeah, there we go. Okay, so there we've just got bubbles, and I don't think the couscous is coming yet, but pretty soon we should have it. I'm gonna go to double speed fast forward here until we start seeing couscous.
Just nailing those invertebrates, huh? Go over there on that
Yeah.
kick up.
Yeah.
Because in these videos, the few that I've seen, these fish don't seem like they're going max speed to collect food. They're like kind of barely trying.
Yeah, they definitely try and be efficient.
Whereas in these tanks, when we
Okay.
speed up the velocity, they seem like they just rip. I mean, lightning.
Yeah. Okay, so here's another good place to do an annotation, which is going to be couscous begins. We don't need a timer on that one.
I wouldn't know how to spell couscous.
And maybe I should
You'd
put.
spell it souk.
I'll put velocity tracers there so that it looks more official and scientific than just listing food, but that's what it is. So anyway, now we're gonna look for
Oh, it's that rain of couscous. Yeah, look at
yeah. So we're kind of when we're going for these, we're looking for some pieces that seem to be pretty much neutrally buoyant and drifting along. What we don't want are the pieces that are sinking really fast, because that means it's just like a negatively buoyant piece that we threw in pretty close to the camera and it hasn't sunk to the bottom yet. So this
what-
one right here seems like it's pretty neutral. So we're gonna do a
I was expecting that you were perfectly perpendicular to the laminar flow of the creek, but are you not?
no, we're not.
Oh.
But we can reorient everything into coordinate system
Oh, okay.
in which like the down, I think it's the negative x direction is downstream.
Okay. So are some of them like that and some of them aren't? You just weren't trying to get it a certain way, or you
Yeah, you just
purposely not?
you don't even try to align it like that, because we can realign it using these cues from the video
I was just thinking 'cause
precisely.
it makes it kind of hard to see which of those babies is sinking versus
Yeah.
floating normal.
Oh yeah, yeah. I mean, we are roughly kind of
Okay.
getting a side view to the current for that reason.
Okay. Yeah.
And because we want to be to the side of the fish too, but it doesn't have to be perfect.
right. Okay.
So, all right, now we're going to add a tracer collection object and click on it and add a tracer drifted event. And we're going to start with this one here. And click it there, and the icon for a tracer drifted event in our type definition is a leaf, because some of the tracers, when we forgot to do the couscous, we're using leaves as tracers. So I made the leaf the indicator there.
Doesn't matter how far ahead you skip to
You want to try and get what's probably representative of the velocity at one point, so you're not trying to integrate over the entire distance that something is drifting, but you don't want to just get a really, really short measurement either.
That'll be something that we'll standardize for the protocol, or
Not necessarily, because it kind of depends. Like sometimes something will shift directions really sharply, and you need to catch it before it does that.
okay.
So in this case, so I got over here and I clicked it in that camera, and now I'm not sure, is it this one or is it this one? So I'm going to use the mouse wheel to back it up here and see where it was. Okay, so it's definitely this one. And I'll just follow it through there to the frame where we've got the hint line, which is the one where we can click on it to complete that measurement. There we go. All right, so 339 millimeters per second. That seems about right.
It seems like it's about 0.4 in a lot of places. It looked like from before.
Yeah, and that is probably about what it was at this site. So then we'll just do that for like 100 more pieces of couscous.
Too bad they're
Which-
not Chinook. My model would be right on.
Yeah. So that takes a little while to do this, but I think we're pretty much done with the demo for this VidSync video. So I'm going to pull up now more of a completed VidSync file, and we can see what it looks like after I've actually done a fair amount of data. So
These are couscous.
these are the couscous measurements. Yeah, for this is gonna run through all 100 of them.
So these are much less laminar because of the shallow water
And the bowl.
Yeah, the shallow water and the
right,
boulders
and
and
the
everything. It's
cobbles.
more irregular.
So how tricky is that for when you're trying to back calculate the distance at which a piece of prey what the was from the focal point velocity and all that when there's turbulence.
There's some imprecision to that for sure.
Yeah.
It's just unavoidable. Anyway, I think what we're going to do to get the velocity at any given point that the fish grab a piece of food or reject it, which is probably what we'll use as the velocity that the particle was moving at, is we're going to use the average of the nearest 5 to 10 velocity measurements from around there. Because I did a test on these and found that was the most predictive of any given velocity measurement, was the average of the nearest 5 to 10 others. So
Okay.
that's going to be
Does
the
there
plan.
need to be a distance thing? They have to be within a certain range? Because nearest, I guess there are enough measured in the visual frame.
Yeah, there
so
are enough
that
in the visual
the
frame, and we
nearest
don't
is
really
never
have.
20 centimeters
Yeah, it's
away
never
or
too far. And
anything.
the other thing is, if we do need a velocity measurement somewhere that we don't have tracers, still using the nearest ones is the best that we can do.
Yeah.
But at the same time, though, because this is a 3D model and you're measuring these couscous, you can actually tell whether or not that couscous was dropping or whether it was coming in flat laminar.
Right, yeah.
So you could actually, couldn't you correct for that then?
Yeah, so we kind of get an.
If you
Yeah,
use
we're
the
gonna have
exact
like
one
a,
rather
yeah,
than
we're
an
gonna have like a
average.
3D vector of what's going on in each location. We won't have, like for each couscous we can tell. And when we're averaging a whole bunch of couscous, just to get the downstream direction, it doesn't really matter. Well, I know there are kind of two different things we're talking about here. One is like the average water velocity,
Right.
and that could, is ultimately going to not have much of an up or down to it. And the other is that we're actually using these water velocities and the surface measurements to rotate everything into a coordinate system in which the vertical direction is the one that passes straight flat through the surface, perpendicular to it, and the downstream direction is the one that goes along the water velocity vectors, and it's defined as being perpendicular to the surface. So that can't have an up or down to it. It's automatically perpendicular to the surface in the way that we define the coordinate system. And I spelled out how to do this in the manuscript that I recently submitted to on VidSync. So that'll
You
be
need
available.
to send us that. I don't have a copy
Yeah,
of that. So.
that's a new thing in that manuscript too. So I can send you that, and that'll be available to anybody who uses VidSync once that gets published, to be able to rotate anything they do in a stream into those nice stream-centric coordinates. So now we can go over here to the Dolly Varden that I already analyzed.
It's really well camouflaged.
Let's see, sort by time.
There's one right there.
Yeah, that's what I'm looking at. Yeah.
The white,
Yeah.
the trick is, as Jason has pointed out, to look for the white vertical
Yeah.
or horizontal bars
Yep.
Yeah.
on the fins.
And the one that we're looking at here actually is over here. It's an enters view event, meaning that this is just right when the
There
fish
is.
comes onto screen, and that was a conflict designated by fighter jets.
God, how many dollies are in that?
Lots.
Are they pretty little? Some of them
There
are
are
real
some.
small.
There are some
It's
really
hard.
little ones. Yeah.
Yeah.
It's hard to tell sometimes.
Yeah,
That one
so-
in the front looks pretty good sized, but
Yeah.
the ones way in the back look real miniature.
Yep. So this is the completed foraging maneuvers of this dolly, and I think 35 minutes of this dolly that we're watching, and this is just the start of it. You see I've got a little timer
Timestamp.
up there of how long we've been going, and yeah, this one was kind of tedious because there was so much of everything getting kicked around.
These guys are a lot more
different
chaotic,
fish
yeah.
coming on and off.
Yeah.
Did you do you didn't do everything for every fish, otherwise I'd
No,
be seeing marks.
I didn't have time to do all the fish yet. Yeah, I think the one that I was measuring went
So-
off screen for a little bit here.
So we should be taking some data on length and also interactions, and then
Mm-hmm.
length of, a dominant versus a subordinate and an interaction. That would be great, and
Yeah.
it wouldn't be too hard to do, right?
No, it wouldn't. Yeah, that's one thing we need to talk about while I'm here. And by the way, I think we can probably shut off the screencast now because we've kind of gone through the whole
Yeah.
VidSync
Okay.
how-to, and